Now let's take a look at the ellipse. It has its own definition, very similar to that of the circle. Instead of saying a circle is the set of points, we say an ellipse is the set of points in a plane such that the sum, S-U-M, of the distances between P and two fixed focal points is constant. These 2 points are going to be called focal points. The plural of these focus or focal points is foci. Okay, just like cactus has cacti as its plural, the plural of focus is foci. And I would like you to pretend that we had a piece of wood here with 2 nails put into the wood there, and that we had a string that was tied to each nail that's kind of hanging between those 2 strings. What we're going to do is put our pen inside that string and pull it taut so that the string is pulled from the nail to your pen tip and then from your pen tip back to the other focal point. I've got a couple such representations drawn here on the right. The blue line would be the piece of string if your point was where my pen cap is, and the 2 red lines would represent the string if my point was down here and on the bottom left. Now, it will always be true that the string is the same length. It's not stretchable like rubber, so the distance 1 plus distance 2, the length of the sum of the lengths of the 2 blue lines should be equal to distance 3 plus distance 4, the sum of the lengths of those 2 pink or red line segments drawn there. Okay? Now, to derive the equation of the ellipse, we need to break this into a couple of cases. The first is that where your point is straight up above the center of your curve. Your actual ellipse here is being drawn in or looking something like this. There's the top half drawn for you. And your string is being stretched from the first focal point up to this point P down to this second focal point P, or F2 I should say. We are going to say that this point P is located B units above the origin, therefore the height here is labeled B. And we're going to say that the distance from the center to each of these foci is C units. And I'm going to use the variable A to represent the length of this diagonal here when the string is pulled taut straight up. We get the hypotenuse of these 2 right triangles in there. Now what I want to do is have you pretend that the string starts at F1, is being drawn here to the left to the first vertex, and then it goes all the way back over here to the other focal point. Notice on the left here how the 2 pieces of string are kind of overlapped. If you were to take your pretend scissors and cut it off right here at V1 and take this short piece of string and move it over here to the right to be between F2 and V, then it would be the same as having 1 piece of string going all the way from V1, vertex 1 to vertex 2. We've already said that the length of the string is 2A units long. A units up there on that hypotenuse and A units on that hypotenuse. So if we look at it stretched all the way across from V1 to V2, we have V1 is A units to the left of the center and V2 is A units to the right of the center. Now the reason we have this case drawn here is, first off, we want to note that 2A is equal to what I'm going to call the string length. Okay. Second thing we want to note is A is equal to the distance from the center to the vertex. B is going to be the distance from the center to, and we don't call this point at the top here a vertex. Some people call it a co-vertex. I'm going to call it the end point of what we're going to call the minor axis. So the end point of the minor axis. And C, by definition, is the distance from the center to the focus. Okay, so this is a lot of writing here, but it's essential that you understand what each of these variables represent. Now let's do a little bit of mathematics based upon the right triangles that you have here. You know that the Pythagorean theorem applies, and instead of having C be the hypotenuse, we have A as the hypotenuse. So let's draw out the Pythagorean theorem here. We're going to have b squared plus c squared is equal to a squared instead of the usual version we're used to. And solving that for c squared, we will have c squared is equal to a squared minus b squared. And that is another reason that we have drawn this out here. Now, turning the page, I have another picture here, but instead of having the point P right up here at the top center, it's an arbitrary point somewhere on the curve, and I'm labeling that x comma y. And I've also kept the coordinates of the focal points here at negative c0 and positive c0 when the center is at the origin. Now you've got a lot of algebra shown here to you in this column, and I'm not going to go through every single line bit by bit. You can read your way through, but let's start and look at a couple of the basics here. From our definition, the distance f1 to p plus the distance f2 to p is constant. That's the two pieces of string, distance 1 here plus distance 2 here there, is constant. That's the 2a, which is the length of our string that we have here. So we have two distance formulas involved. We're going to simplify these radicals. We're going to isolate one of them on the left, so we have 2a minus one of those radicals. We're going to square both sides and then go through a whole bunch of algebra, which I'm going to forward through. At some point you get to a place where you've got too many variables involved, so you're going to change c squared into a squared minus b squared, which is what we learned over there on the previous page. And after we do all this simplification, we find out that x squared over a squared plus y squared over b squared is equal to 1. And that is the general equation of an ellipse centered at the origin. Very similar to your equation of a circle, x squared plus y squared equals r squared. But for the ellipse, you want the equals 1, and instead of an r squared, you want this a squared and b squared down in the denominator. If we take this one step further and move up to the top of the next column, I've changed out the x squared for x minus h squared and the y squared for y minus k squared and set that equal to 1, because that will now be centered at h comma k instead of the origin. And if you want to find the foci using this form, we're going to use c squared equals a squared minus b squared. Basically, you're going to be subtracting your two denominators to find the value of c squared.